So welcome. Here we have our 7th lecture in software architecture. I guess most of the students are out seeking for good job opportunities. Nevertheless, they will miss this interesting lecture, but not really, because we are recording this course so they can have a look on software product lines, which are an organized and affordable approach to software use that actually really works. You all know that software use has been kind of an outstanding goal in software development ever from the beginning, practically. So this is something that is not limited only to software development. We all want to reuse things, not to do things repeatedly and so on. However, what happens is that you cannot predict all different circumstances of those new contexts for reusing the things that you develop. And in software development, this is probably the most prominent or most visible. As soon as you develop something, you want to change it and so on. So ever-changing environment creates thousands of opportunities and problems and everything that you need to count with. And you don't have to talk in general like this. We just have to recall that we're using when we're programming, we are programming to using some parts that we rely upon. Usually these are some frameworks or libraries sometimes that we use, that we call those functions that are implemented there, or rely on a whole framework to do some things for us, and we just add some things there. So we program things, we develop our own ideas, but these are in the context of what is there provided. And when these things change, what you developed is no longer reusable. And to imagine that from one framework you can go to another framework and reuse all those things that you need to reuse, it's kind of very difficult thing. It has been tried. There have been component systems that enable you to reuse, to transfer components, to have components, component markets, whatever, like this. But the problem is that things are not that easily connected. We might think that, oh, how bad it is in software. Look at we don't have to go outside computer science, or computers. Look at hardware. So they can manage this, and not if you go a bit outside of our scope, like TV sets or whatever. But when you open a modern TV set, or not now, but some decades ago, TV set that was modern at that time, you would find components there. Okay, there will be some recognizable components like resistors, transistors, or whatever, but you will not be really sure what is what, and they would not be even marked as you are. There are certain conventions to mark them. So reusability of these things, and many of these things were custom developed for a certain line of TV sets or whatever. And within that line of TV sets, they were usable. So probably the problem is that we set our goal for achieving reusability a bit too high. And we need to go to limit this in scope. And then we might be successful. So a certain line of TV sets or certain line of applications that share some features and can be and they're actually built within one organization. It's not that we want if we set the goal to develop things to share with all the organizations and to have reusable components for all of them. This is an overkill. So, how to approach this? I'd like to remind you of this scheme that we had in one of the previous lectures, where we distinguished what the system is and what the system does. We talked about use cases on one side as a kind of end-user mental model reflection, and on the other side, domain analysis, which gives you more stable structure you can rely upon and you can identify without actually specifying use cases. You don't have to specify use cases and then dig through them and look for domain objects. They will be to some extent there, but you might very well miss many of them, or even most of them, or they will be shaded by some other objects, but some other objects which are actually behave more like roles. You will perceive them as objects, but these are actually roles that your domain objects play there. We talked about this with respect to the approach called data context interaction and with respect to preserving use cases in code. I'm not going exactly this direction now, or this is not my primary intention, but my primary intention is to emphasize that also this perspective of what the system does is tends to be needs not be exactly maybe, but tends to be a single customer perspective. So you have your customer or client and you ask them what they want, or him or her, actually, like to not many many different customers. Like you have one client, one company that actually wants some software from you, and you ask them what do you want, how do you want this to look like. So this is custom developed software. You can imagine your client, but again, your customer or end user. But again, this is if you're developing a piece of generic software. But again, this is just one application that you're imagining there will be possibly configurable to some extent, of course. But you do not think of building or like dozens of applications over a period of maybe a decade or so. And this is what you do when you think in terms of domain analysis. It's kind of all customers' perspective. You think of not just exactly the customers that you have right now, but any future customers that might come to you. Again, how would I say this? So resources are limited. This is a financial issue. You don't have money to simply cover all possible things. So this is not this thing. This is the thing is in taking a feasible all customers perspective, something that you can achieve, that you know and you are willing to invest money in. And later we will touch this a bit more, this issue. But software product lines are not a kind of dream approach about something. They are highly calculated in in taking care of what is feasible, what is achieved, what can be done, and what you really want to do, and that you need to make money out of the software that you deliver. And you cannot make money very much. Maybe you can if you sell these assets that you develop, your analysis. Sometimes this is being done. There are companies that analyze a domain and then are selling these the assets they have with respect to this analysis. But this I'm not sure. It might be kind of like it's somebody else's work. There's a huge analysis, and you buy these things, and you think you will learn everything from this. You need your own domain experts in order to efficiently develop software in that domain. So it's not for no reason that agile approaches speak about cross-functional teams and favor cross-functional teams and so on. That you need the people that know the domain and that you can work with them directly and then turn these things into code virtually. So anyway, we want to take this all customers perspective to some extent, and for this we need to cope with domain knowledge. Here's one definition by Koplin and Bjorvik. A timeless compression of the mental models of end users and other stakeholders. Mental models whose patterns are tacitly driven by commonality and variation. So this definition speaks of if we get back to what I was showing here, if you would compress these things take each and every user or alleged user of your system, and you compress their mental models, you would eventually arrive at what you have here. But this is not how you actually do it. This is not how we would do it, because this would take too much time. So it would be again an overkill. But if you just starting with a domain and you have no knowledge, then that's the only thing you can rely upon, and you will eventually compress the knowledge that is embedded in some of the systems that you produced before you start to develop something called software product line. So this is one part to it. The other one is down there, commonality and variation. Why is this important? Why would be commonality and variation important for use? Well, commonality is something common across many systems and something that you can just incorporate in your different systems and use. So all your systems will have this common part. And variation is where the differences happen. And you need to have this perspective on your mind as you prepare for the development. Because if you spoil this, you will not be able to implement variation efficiently. If you have some knowledge, or you assume that you have sufficient knowledge of your domain, you can approach it by exercising domain analysis. Domain analysis. The goal in domain analysis is to capture domain knowledge by looking at the practices and systems in the domain, as well as practices and as well the systems in the domain, because many practices might not be even documented very well. So today we have when the first banking systems started, no other banking systems were there, or whatever, or some other information systems. You could not rely on these things because there were none. But you had to rely on the rules of the domain instead, and the nature of the domain, and how things happen to be performed manually. Today, you need to combine these two perspectives, because much of that knowledge, how things are performed, are actually just implemented in those software systems and are not accessible by other means. So the domain becomes enriched by each and every one system that is implemented within it. When you deal with domain knowledge, you might ask yourself how to represent it. What would you suggest? So we're looking at a domain. What would you use, possibly? You might use UML. You might draw simple, not with all the details that might be there, simple or simplified, not simple in terms of the number of the elements, but simple with respect to what features you use, simple or simplified class diagram. Or you could describe the domain knowledge somehow. Then you would talk about classes, or in the end, objects that are there. But are objects appropriate for this? Do you know that you're going to implement this system completely in an object-oriented way? Isn't it too early to bind yourself to object orientation? Can it be more general? Because you might have other different options, not just procedural ways of expressing things, which might be even, in some cases, for algorithms more appropriate. But like functional or application, is it called also programming ways of expressing things, which are kind of functional programming was popular very much some decades ago already, and then they thought even, and I think even they developed some native some processors, computer processors, with the native support for functional programming. For one of the prominent programming languages, functional programming is Lisp. And there was an idea that this would be this would be the future, but somehow for the major part of software systems is being developed by using object-oriented technology. So you can easily compose things, put together things, and this perspective seems to fit very well with much of software development as a kind of framework paradigm for it. But occasionally we slip into some other paradigms, and one of them is also functional programming, and some functional programming features have been added across different programming languages, and namely Java incorporated not that long ago some aspects of, in a very limited sense, functional programming. You know about lambda expressions. Well, they are used the way they are used, but maybe these things will develop further. The idea with functional programming is more like to express everything in clean functions which have no side effects, and then you can prove that your program, or see clearly that your program is right. So because it's not messing around with some other things and not using global variables or such things. Just you are passing functions to functions, and you are passing function to deal with the data. And this is modern like the approaches that deal with unstructured data mostly work this way. Map, reduce, and such things. So it might not be very right to bind yourself to object-oriented technology directly like this. So instead, we raise a level a bit and talk about domain concepts. And we do not want to specify too much whether, if we would be talking about classes or objects, so we will be seeing things as like through their relationships, which can be, well, you can have an abstraction of that as a relationship which is being called association, but usually you need to specify this more, so you have aggregation or inheritance, and all kinds of dependencies because they are calling each other and so on. But you don't want to rely on these mechanisms and overriding of methods and such things. You don't want to bother with these things. So you want to speak about a general perspective on domain concepts. And if you recall that, as I hope I convinced you a bit already, that commonality and variability are very important. So you want to talk about domain concepts and which domain concepts or their parts, their features are common, which are variable. And then you can decide on implementation mechanisms. So features are sufficiently neutral to talk about concepts. And then you decide how, and each feature in the end it might be perceived as a concept in its own right. So it's a concept of a concept, but with a regard to a certain concept, it behaves as its feature. What do I mean by features? Let's analyze this a bit. Let's take the example of an eShop, and talk about what possible concepts could you identify there, or let's talk about the concepts. Let's say concepts in the eShop, and then we'll will bind the things together. But just for the starter, let's think a bit. Should an e-shop provide product search? You want to develop a family of e-shop systems, and to be successful in this field and to sell these systems, and but you do not want to invest too much money in it, of course. You want to earn more money, but you don't have too much money to invest at the beginning, so you must be very careful what do you want to include in the product family that you're developing. So what would you say? Should an e-shop provide product search? Could be interesting. Is it necessary? Can you imagine an e-shop without product search? No?
Is it show when you sell one item?
When you sell one item. Okay. Maybe even if you sell 2 or 3 or 5 items, and if they don't change very much over time, or you are adding just like once in a few months you revise your product list, you still might be very successful because these are specific items that you're selling, and you're offering good prices, and people somehow learned about you, and things are working. So such an e-shop wouldn't even like what sense it would make if you would have product search. So if I would be buying an e-shop system and I'm selling just a few items, then I would say, okay, just give me the cheapest variant that you have of your system, because I don't need those advanced features. What other features can there be? I don't have the question in the slide, but I'm asking you. So one of the things that could be there. Let's talk about things that could be there, not that are necessary. Then we will, or we can start marking them. So I would say that because we already understand this, that product search so this is our e-shop. This is product search. What other features could be there? Just product search. And it might not be there even, so then your system will be empty. And it will be very cheap actually to implement such a system. But who would buy it? So you don't have to be too careful when specifying features. You might be like one of the key notions, key concepts in selling things not just in e-shops, is, or maybe the most important thing there is, an order. So I would say order. It should be there probably. If we would not have a way to make an order, so I can mark it like this field in circle, and this is a possibility, an option, an empty circle. Order. What else? The concept of payment, because you want to get money, so payment probably should also be there. Come on, don't be too modest. Now it's not the time to be modest. You're just doing some kind of analysis. You can decide. You're just writing your concepts on the paper or this tablet. It's a very cheap activity, very cheap thing. You can get rid of them very easily, delete them, remove them, decide not to have them implemented. You don't have to remove them actually, maybe. Maybe you have to record them, have them in your analysis for future reference because you consider them and they might be affecting some things that you are going really to implement. You're not going to cover everything. For example, registration of your users might be there or not. Another optional thing, registration. So, kind of many different things, and this payment. How can you manage the payment? Can be cash, card, or some other things. Yeah. So like there are different options. You could say like cash, card, and it's open. And card can be, I don't know, credit card. Maybe you have limited support for debit cards. You prefer credit cards for some reason or whatever. Or different companies, different card providers. Maybe this is not the case, but whether it's MasterCard or Visa. Maybe this is where the thing is. MasterCard. Is it like this? I'm not promoting them. Different kinds, maybe we'll add some other kinds there. Because the implementation, the interface to them might be different. Because this is not just that you name them. When you decide that you want to support them, you will need to implement some things around this. And even this is the first level, second, the third level of your list, and still it doesn't mean that that feature that is deep down will be that easy to implement, but it needs to be kind of pluggable because you can support only MasterCard or Visa, or you can support both of them or some other as well in parallel. And there might be some interference between these features. Might not. we will look at this. I have a bit different elaborated example, but what comes, where are we getting with this is that this starts to look like a tree structure. So actually, I can even switch this, like have it bigger for the time being. And switch back. So product search, order, payment, registration. These are related to eShop. So we could say that these are kind of, I can connect this, maybe I can have this edge, like a combined edge like this. So one edge. And eShop is also a thing to consider. This is your main concept. You can have this product search. Product search can be done also differently. Might be some variants, some simple or advanced product search. Also, you can use this tree structure to structure this, and then you can tell even that this is a kind of basic product search. I would maybe put this product search there. And maybe not. That's the question of the style. So basic, it looks worse and worse. Basic, no. Advanced. And do you need to have both of them? No. You need to have one of them. So you might indicate somehow this. And one way to indicate this is by this arc. So this is an alternative. These features are alternatives. Only one can be selected. But maybe you don't want only one to be selected. Maybe you can have both and switch back and forth between them. So in that case, you might decide to fill in this arc. And it will have not XOR meaning, but or semantics, but OR semantics. So you can have either one or both of them. But one of them has to be there. And you can even imagine a more complex specification of choices. But usually in software development, we distinguish between 0 occurrences, 1 is significant, and many, maybe sometimes 2. And this is the kind of so deep, related to our mind, to how we perceive things. And there are even natural languages that have no other numbers but none, 1, 2, and many. They do not bother counting how many. So probably this is how we all started, and this is the basic thing for us. And in software development, we rely on these things that are set very deep in human mind. So we have this eShop, and product search here is a feature of eShop. However, we can take this product feature like a separate concept. Then we can still make a reference here. Here I'm showing this here at the tablet, but I'm not moving actually. Maybe actually you see this tiny dot. Yeah, because I'm moving. It's nice. So product, we can retain product search here, but not with this part, this elaboration. So we can elaborate it in a separate diagram like this. And these diagrams, like this, and these are like mandatory features. These are optional features. Roughly what I'm showing you now is the notation of feature diagrams. Feature diagrams. They're not called concept diagrams, but they're used to model concept using features. That's why they're called feature diagrams. So if I show you a bit elaborated diagram on Microsoft Edge. So all the items, I had it displayed as order. There might be different ways of expressing features and different ways of even organizing them, because the dependencies might be like not in a tree-like fashion. For that reason, we can have these separate additional rules, like this from the catalog implies catalog. And if we look at the diagram, we can see that this is the catalog. I've forgotten about catalog completely. So this is in a way an alternative to search products, but not a real alternative. It's an optional thing. It can be there. It doesn't have to be there. Not even search products have to be there. By catalog, I don't mean really a simple list of products, or maybe I do. I don't know. It is not enough just to name features. You need a bit of description. It's just like with use cases. It's not enough to name use cases or sketch them in a use case diagram. Actually, it's not good to start with a use case diagram. On the contrary, it is good to start with a feature diagram. However, it's a kind of acts like a mind map, but you have not to forget to make notes to your features, about your features. At least small descriptions. Sometimes behind your feature there needs to be a more elaborate model, more like something like maybe you can use class diagram, a very simplified version of a class diagram, in order to explain what do you mean by that feature, not relying very much or at all on object-oriented mechanisms. So what do we have here is also this that catalog and this separate rule that defines additional rule that defines an additional dependency that is not depicted in this diagram. So catalog. From the catalog is the feature displayed here. So you can, when you're ordering items, you have to support the select products feature. You have to support how one selects products, and this can be from the catalog directly by search. These are alternatives, and one of them has to be there. Actually, I assume that only one can be there. Only one of these features. I'm not really sure now that this is correct, because I might like my software systems to support several of these. So this should be probably an OR feature. So it should be a field circle. A field arc, just like this one here. Nevertheless, when we look at this rule, so if I choose this feature from the catalog, I need to have a catalog there present. So suddenly this catalog feature becomes a required one because it's required by this one. I could draw an arc here or some edge around here and connect these two features, but I would make a mess out of this tree structure. How do I choose what goes into the tree, what goes outside as these additional rules? By importance. I develop some perception of some things. The most important things, I want to have them visually expressed. This is not, I must admit, this is not a notation that is probably, I'm not sure, maybe there have been some situations that people use this in practice, like for the practical software development. Usually they maintain these feature lists. These feature lists are maintained, but they're maintained in custom systems, maybe in spreadsheets, even or whatever, or maybe they could be drawn as UML diagrams, as class diagrams, and actually not just class diagrams. And there's an elaborate approach to this, how to use UML to express the features in your domain. So you don't have to, you can use any of those elaborate, well-established UML tools, or whatever UML tool your organization uses, and interpret all those diagrams that you draw there as feature diagrams. But as I said, probably this ends up as a list of features, and the elaboration is in a fashion of tree structure. So if we go further, as I indicated also here, this product search or search products feature can be basic or advanced, and we can choose one of them. I decided here that it is one or the other or both of them. But we can indicate this is another way to express what I've drawn here by this field in arc. One or many. So using cardinalities. Using cardinalities. This is not a cardinality attached to this edge, but to this arc. And slight changes are happening. I can add this here as well. If I put this here, then this feature diagram also could be valid. Even if I think in terms of this, because maybe at one point in time, you can have like only one feature active. But you're not modeling with feature diagrams. You're usually not modeling. You can use them to model the current state of your application. So then it holds that only one feature can be selected at one time. But you're not using them usually to express the state of your one application, but a state of the family of applications. So any of the applications in your family can use can include from the catalog directly and by search, and you can inside you can switch or not be. You might be able to switch or not to switch between these features. This is indicated by something It's called binding time. And if you say this happens at runtime, then this is that kind of flexibility that I explained, that you can as your application is executed, your system is executed, you can switch between these features. But you can also say that these features are bound at compile time or at source time. So that's when you decide that whether there will be these features or not. So what you're modeling here by this simple notation is variability, mostly. Like, you're targeting variability. Those other features that are mandatory and bound directly to this high-level concept of eShop, they are constituting commonality. However, you can see that you can have a common, or you can't really see this here, but there could be common features hanging on your variable features as well there. So then it is a commonality of a variable feature. So these things are not that simple, that this is a common thing, this is a variable thing, but they're combined and interleaved like this. And you decide upon including them or not as you go through this tree. And you can model situations. Like you can model classes to represent your systems, provide a general view of your systems when you use object-oriented, the object-oriented approach, and then you can depict certain objects and how they are connected to each other in a kind of an object diagram to show a particular situation. Here you can use the same notation of feature diagrams to show what is selected. All these features become that were optional I decided to select them. So search products is also, I decided not to include search products, but I decided to have it, so they become mandatory for my eShop instance. However, these features here remain variable because they have runtime binding. It means that they will be selectable and decidable during the runtime. Whether they are, one perspective is whether it is possible to engage them. The other perspective is whether it's possible. So you have a configuration where you decide whether this is possible to have them within your system, or you just have them and a user can use them and switch between them at their own convenience. So they remain even in your instance like this. You can have all your variable features like this. So then you will be developing virtually like one system which is highly configurable. So this approach is also possible in software product lines. These are dynamic product lines. However, you know that with any feature that you can you include, your system becomes bigger and maybe the performance issues occur. But most of all, you lose money because you will be delivering one system to all your customers, and all your customers will have access to all the features. However, you can lock some features. You know these systems. You saw many applications, and you have many applications like this. And there is sometimes community version of an application and a paid version of the same application, which actually is the same, but with some and you do not have to install anything there, but you need to pay in order to obtain some the license code. When you enter the license code, you unlock additional features, which are already there. Sometimes it's easier to do things like this. So this is the thing that you need. Dynamic software product lines, as I mentioned. This is the thing. This is how you can approach domain analysis. So I'm not when I draw these feature trees, feature diagrams, I did not think of how these features are going to be implemented. I was thinking primarily about how they interfere with each other. What are these features, first of all? Let's name the features. I organized them. How are they related to each other in terms of which feature requires which one, cannot exist without that feature. Some features are mutually exclusive. And when I express these things, and I know what these features represent, I can decide for appropriate implementation mechanisms that will allow me to maintain this software product line, to include or exclude features as I need to do this. So I let myself be driven by commonality and variability, and then I think of how to implement features. Some things, when you look at these search products, some things might become quite obvious. And when you decide for a particular, you know that you are limited to object-oriented or oriented technology. So some things become quite easily decidable. So what do we have here? The search products can be basic and advanced. So it might be, there might be different options, of course, depending on what you need. So one thing is that you can have this. Maybe this is a better option. So product search, or whatever we call it. And there are two implementations of it. So this might be an interface, might be as well a class or an abstract class. And these are variants. Actually, these are different kinds of implementation. So basic, let's just call it B, and advanced search, so that I don't have to write too much. So basic and advanced search, or you can imagine this, like you have basic search and your advanced search is derived from extending your basic search. Must be careful here, because you might be interfering with Lisko substitution principle, which is something, or some other object-oriented principles. So in this case, the first one, that's highly unlikely to happen. I don't know about this case. We would need to look at the operations and see how instances of A and B are used, and whether they are really whether you can always put an A where B is expected. This is what, roughly speaking, a Liskov principle of substitution or a Liskov substitution principle is about. So you start thinking this way and you develop your structures accordingly so that you can include or exclude things as you need them. So all in all, what we saw is that abstractly captured variability enables to decide about implementation mechanisms responsibly. So you first go with your commonality and variability analysis or domain analysis, driven by commonality and the variability, and then you decide for implementation mechanisms. When you do this, how do you maintain your software product line? What do you need to do? You need to produce some software. You need to produce your components, whatever they are, components in terms of maybe there will be frameworks, small frameworks, whatever, or small parts or a bunch of classes or whatever that implement certain features and that can interact with other features as you need. Some things might be even generated, so you might be producing your custom generators of code that are highly configurable according to your needs, and then they produce highly customized code that you incorporate in your system. So you need all these things before you can produce a single member of your system or of your product family. So the process roughly looks like this. So if we move, but it's big enough, I think. I don't have to make it bigger. In the upper part is what I was talking about. So domain analysis, this is mainly, which is mainly based on commonality and variability analysis, but however you can analyze and elaborate on different concepts they're using, I don't know, maybe even ontologies or whatever you need, or just simple class diagrams, whatever, just to elaborate the structural part of your concepts. Sometimes it's necessary to understand them fully. Then you develop when you develop your domain model, you proceed with designing things. So you make design decisions. Here you are entering your solution domain limitations, and you decide for the solution domain and how you implement things, and then you eventually implement things. But you're not implementing your system. You're implementing generators, components, maybe even domain-specific languages, small languages to express what you need to express. Only then you meet your customer, you take the requirements, because you're not going to tell your customer, okay, I have here lots of features and I will select some for you. You want your customer to select the features so you can show them what's possible so they can select the features. But usually they do not want to just to pick and choose out of your features. They have their own requirements and you need to follow them. So you mark their requirements somehow and to understand their needs. And then you, based on this, hopefully, if you did a good domain analysis, then you should be covering all of these requirements, ideally. But that might not be so. So there might be some new requirements. So, but for all those requirements that you do have, you translate them into features. That's your language. the language of your domain analysis. These domain analysis features and concepts map to design elements, implementation elements, and there are indeed many custom environments hidden from our eyes in companies that work like this. So you have this high level of commonality variability perspective embedded into code or like coding environments or interleaved with coding environments. So you configure your code directly. You bypass this modeling perspective or whatever, and you simply configure your code through your features. And there will be, in practice, new requirements, the requirements that you did not consider, did not cover by features. So you will need to do some custom design within a member of your product family. And of course, you need to integrate all the things, and the custom design leads to custom development. Finally, you end up with a product, you're happy you deliver it. And you go on like this, but you should not forget to get things back into this upper part, which is called often domain engineering. So you're engineering a whole domain. Sometimes the whole process is called, the whole approach is called not software product lines, but domain engineering. But more specifically, when we say domain engineering, we mean by that this upper part of the process. This part downside of this slide is called application engineering. So engineering application based on the things that you produced in your domain engineering. So you should not forget to get things back into your product line. So roughly, this is how things are organized. Still, this does not say directly how to approach things. When we maintain software product lines. And one of the things, just not to forget, and we develop software product families within them. So software product lines, software product families. Sometimes these terms are kind of interchangeable because products are related to each other. When we say software product line, it's a line of products, like a line of similar cars, a line of similar TV sets, a line of, I don't know, perfumes, line of other cosmetic things or whatever. It's a line of these products. It is not a factory line. It is not a line when you have people standing and each one of them doing particular things, and so they're passing the product and like doing. This is not the metaphor. The metaphor is on this side, not on factory lines. So a line of products, a set of similar products. Maybe this is not quite strictly a line, because you have one product and then another product which is related to it, and then another one is related to this one, and the other one is related to this one, but these two are not that much related, so it becomes to look like a tree structure, something like a feature diagram. And this is more related if we talk about these assembly lines, factory lines, which are known from the fourth approach. This approach of analyzing the whole domain and deciding what to implement, what not to implement, is more related to the lean approach, which was established and promoted by Toyota, and eventually influenced our field that much that you are now using to organize software development. Even now, if you're within your team projects, Scrum. and it's rooted very much practically. It's rooted in the lean approach by Toyota, formerly Toyota. So they were not producing, not even producing cars at that time. They were producing these, what's it called? Those machines, not sewing machines, but those machines that are making materials, like textile materials, like, or even carpets. What's it called? Loom machines, something like that, to put together threads into a material. So these things. The organization of people, of work, and how they approach this, and how the philosophy of not producing things that are not needed, right on time delivery and such things, they come out of this philosophy. How to establish software product lines. As I said, that scheme that I showed to you does not reveal how should we approach establishing product lines. Sometimes we call them just product lines because we know they are software product lines. One approach is to decide that you're going to have a product line. Get some money, or a lot of money, because you're not going to earn any money from this during the establishment of your product line, and establish it. Revolutionary. So you decided to do this. You don't have any products of whatever kind that are related to this. You're developing the components from the beginning, your domain-specific languages, generators, or whatever you need to have there. This is the situation, like no product base. Revolutionary, no product base. The combination of these two things. However, you can also have some products. And this is probably more probable that you will have several products before you decide or you dare to establish a software product line. So you have several satisfied customers, and you observed that you are selling them a lot of same things, but there are some differences, and you have some difficulties with coping with these differences. You see that you need to kind of stop for a while, or as part of your team develops some products for particular customers, and you're earning money. You put some money, invest some money in the process, and take out the features of these products and put them in your software product line, so that you can more easily reuse things that you're producing, and not just reuse them like quickly and just like frantically put things together for a particular occasion. So in that case, you will probably approach the thing evolutionary also. So we will not stop completely and say, okay, I have these 5 products. Let's tear them apart into features, or dismantle them into features, and implement these things so that they're composable, and that we can cover all the things that we need. We will not produce we will not continue our producing our products until we set these things right. probably you will continue producing your products, and there will be new features arriving. So you do this evolutionary, and you put into your software product line as much as you can, but not more than that. What you can do, you can do. So gradually you will build a product line out of the existing set of products. It will be getting better and better over time, probably. If you will not be if you wouldn't have to serve too much user requests for new systems, so that you can't invest into maintaining, establishing, or developing a product line. Of course, these are like this looks like a matrix, and it is a matrix, but not that kind of matrix. So there are two options, most prominent options probably, but also you can have no product base and approach things evolutionary. So you start developing your products, and also you take some features out of them and put them in your software product line. But you have no previously. You consciously decided for a software product. Not that probable as this situation here. Also, the fourth option would be development of a new product line out of the existing set of products before delivering the first product. So you do have this existing product base, but you decide to stop things for a moment, and from now on, some of the things will be in the product line that you're going to establish. So these are the options. Needless to say once more that this gradual development of a product line out of the existing set of products is the most probable way to go with software product lines. Also, maybe it is good to say that many organizations, many software development organizations do use software product line approach, but they're not aware of it. So they cannot fully, there's a bunch of literature, it's not just about what fancy systems, what tools you could use or whatever. It is like Scrum. What is Scrum? Is it Jira or whatever system that you use? It's actually probably goes against many of the principles set by Scrum. When you more carefully have take a more careful look at these things, it is an approach, an attitude that generates then a community of trust of developers who collaborate frankly to produce something good. And not because they have to report some tasks to some manager. But for this you need to set other things also right. So that is something that you can address with organizational patterns and gradually build your community of trust like this. And what is it? Is it a software tool that helped you? Is it a kind of a software process that you put in charge of the organization, and then that actually made things work? It's not like that. So also with software product lines, many things, if you become aware that you need to deal with commonality and variability, you don't have to actually maybe use that funny notation of feature diagrams, but it is a question of of the attitude. So this is roughly it. I have one more thing with respect to dealing practically if you need to use UML to express things and to deal with variability. You might think there's not very much there to use, and you would be probably right. But there are some interesting things in UML. Maybe it's a pity they're not that known, and it's a pity that they are not maybe they have not such a good support in tools. And there are also yet another bad thing that they're quite lousy described in the UML specification. What do I mean by that? I will show you in a few minutes. First of all, look at this example. Not that one up there, but this one down there. Do you recognize this? Have you seen this before? I assume you understand this is a class and this is another class. But what is this? It's a bit different than your normal UML models, but still, this is plain UML. No additional things. This is a parameter box. So this is a parameterized class, some kind of array. It has this feature of contents, so it's just another way to express that this is a part of this class. We could set this as a simple attribute as well for the sake of this example. So it's just an array of type T, so 0 to K occurrences, where T and K come as parameters. So we'll get them from the outside world. And the outside world is here. So the outside world is not really supplying these things here directly. Actually, T is supplying these things there. And at the same moment, it is realizing this thing here, implementing this thing, realizing it, as another thing. So this address list is your F array with these parameters. So your T is an address, which is another class in your system, and your K is just a number. It's just an integer expression. So integer expression of 10 is a default, but here you set it to 3. So you end up with an address list of 3 addresses. It's a bit strange. This is a list. This is an array. But that's just an example. So let's forgive them. So because an array needs not, you can use arrays to implement lists somehow, but an array is a bit different structure. Doesn't really matter. We see that this is actually an array, not a list. So this is address list, this address array. This upper part shows the same thing. So this is the latest, not completely the latest. I think 2.5.1 or 2.5.2 is the latest specification. But I guess, if I'm not wrong, or maybe even 2.5, not 2.5.1. Not too many. They were updating quite frantically UML specification during some period of time, but in recent years, I think there is no update. No, the latest update is from 2017, if not this one, 2015. So here you have completely wrong arrowheads. So don't be fooled by this. This is the right notation. This is an older one. This is 241. And this has been reported as a mistake, as an error in the UML specification. So this is the same thing, but this error, and it's not even dashed. This error, you know this error without this stereotype realization. So it's a common thing. Here, never saw this error. No, I don't know. Open issues, yeah. You can even click this link in the slide. But why I'm showing this, because there is a this is a more interesting example, and another yet more interesting example which uses this wrong notation for parameterization. You can not even parameterize classes. You can parameterize packages. And this is something that has been imagined in aspect-oriented software development some years ago, before this was added to UML. I don't think they ever referred to that book that proposed parameterization of packages. However, that book, again, does not refer to some work of Trygve Regnskog that relates is related to how things are composed, and it could. So we are not very much referring to each other. And then it seems that there are, like, even in scientific papers, there are problems with this, that we are very, very, very easy on references. Not like in other fields. So we should be referring to all the things that are similar, related, and that's why it's important to have related work even in your project report in this course. So here, our parameters are all classes expected, like resource kind, system. No that integer kind of parameter, a simple parameter, but all classes that we will support here to this mechanism of resource allocation. So this is a resource allocation which defines how resources are allocated, in what time slots there is a request, there is a system, and so on, and resource kind, and system. So resource kind, and system are expected to be delivered here to this mechanism. So these are our classes that we can bind like this. The arrow here is wrong, even this 241 version. So of course it should be like this. With that stereotype bind. So the error is wrong, not that wrong as the one that I will be showing you shortly. So what we do is we say that our resource is a car, our resource kind is car specification, our system is car rental system. We bind these classes, and this mechanism is a highly generic mechanism for resource allocations, and we need not implement a specific one for our car system. It is good enough. Just we need to say that it is about cars to bind specific elements. So this is a bit different composition than they are used to, and you can make use of this to express your variability. or address your variability. Here is this this more interesting example. This more interesting example makes heavy use of these strange arrows. Here, these arrows should have been those normal arrows. Although these normal arrows here, there's an interesting thing that actually whenever we use, but I think everyone does this, almost everyone, or maybe in some normative documents it is not so. So you have arrows like this, and you may note that in UML you can have this dot, and I can link a document that explains the difference between these things, but the issue is in whether we want to express navigability or a reference to something. So usually we do not distinguish between things, and I don't think that UML from one point introduced these dots. I don't think that it's not. I think it's not even supported, not even in Enterprise Architect by now, for example, and so on. So these things are not quite established. And what to say then about these more complex and more interesting things? So you cannot be mad at tool developers that do not implement such poor specification. So here the principle is very interesting. You can have two bindings of the same parameterized component. This is a kind of a parameterized component expressed as a package, parameterized package. So on one side, in your training administration system, you need to manage your instructors. On the other side, you need to manage facilities. The problem is the same because they're both taken as resources. And you can put together both things or make two bindings. So your structures will be, these structures will be to some extent replicated, but also overlapping in some things that you use because we will be reusing the same mechanism. It will not be replicated there for resource allocation. But on one side, you will have your resource as your instructor as a resource. On the other side, your resource will be facility. A very interesting thing. So this is actually doesn't really matter. This is a UML meta model, but it is so really that a package is a templatable element. Can be a templatable. Actually, you can have a template on a package. So I actually. Doesn't really matter. This was my intention, just to show you that it is a templatable element according to UML meta model. So UML specification is not just, and this is that tiny dot that I mentioned. The UML specification is not just a bunch of text that describes what UML is. And bunch of examples. It is a bunch of diagrams as well that express the abstract syntax for your modeling. So, in this part, the second part, I try to show that regulated variability within a domain is a basis for achievable software use. And I provided you with some ideas how to organize work when you want to do this. I will end with these two notes displayed here, and if you have any questions, remarks related to the lecture or whatever, you would like to ask regarding the course? Okay, it doesn't seem so. We will continue next time with distributed software architecture, followed by maintaining software architecture, and then there will be this container-oriented software architecture and its implementation, the guest lecture that I promised you, and the final lecture will be on aspect-oriented modularization. So this is our plan. Anything else? I hope the things are going fine with your projects. I did not hear otherwise from your teachers either. Okay, see you next time. Thank you for coming. Thank you for your attention. The next time, this distributed software architecture, we are getting back to patterns. Okay. This is for masters.